Hello. In this video, we'll see a few questions and how we can answer them regarding the topic 1.4 of relative motion for the grade 11 ASP mechanics course. Now, the key concept of the theory is the topic of relative motion. One example of the topic of relative motion is the following, like if we have an observer that it is standing on the ground. I'm calling him observer A or person A, and he's watching, for example, a train that it is moving with a speed of, let's say, 10 meters per second. This is the speed of the train, and inside the train there is another observer B, and maybe a cat or a dog that it is moving inside the train. And inside the train, the speed of the cat could be 5 meters per second. This is the cat C. Then what the observer B, that it is standing on the train, sees for the cat is the cat moving with a speed of 5 meters per second. However, the observer A, if he could observe the cat, he would see the cat moving with 5 meters per second inside the train that it is already moving with 10 meters per second. So for the observer A, the speed of the cat is 15 meters per second. Now, the laws that command, the equation that commands this, what observer A measures, what observer B measures, or what the cat measures, is the following law, that we can say that the speed of observer A with respect to B, or the speed of object A with respect to B, is equal to velocity AB. In a similar way, the speed of A with respect to C, we call it speed AC, and the speed of C with respect to B, we call it velocity CB. And if we have this notation, then the velocity of A with respect to B is equal with velocity of A with respect to C plus velocity of C with respect to B. Going back to the previous example, we could say that the velocity of the cat with respect to B, we know that it is 5 meters per second. The velocity of the train, or actually the velocity of the person that it is standing inside the train of B with respect to the observer A, is 10 meters per second. And if we need to find the velocity of the cat with respect to A, the velocity of CA will be equal velocity of CB plus velocity of BA. So we need to make sure that we have the first letter appearing first, the last letter appearing last, and the letter in the middle appearing at the same time. So we say that velocity CB is 5 plus 10, and it is 15 meters per second, as we expected with common sense. Now let's do a few questions from past exams. What we have is the speed of an airplane, that it is moving east. So we have a plane that it is moving east with a speed of 350 kilometers per hour. However, the wind is blowing the plane north with a speed of 40 kilometers per hour. And we need to find what is the velocity of the plane with reference to the ground, relative to the ground. Now, here we can answer with common sense that since the plane is moving east and the wind blows it north, the velocity of the plane will be exactly in the diagonal. The actual plane will be moving north and east, and we can say directly, we can apply directly the Pythagorean theorem. However, if this doesn't make sense, we can say that there is the speed of the plane with respect to the wind, I think the airspeed, yes, since this is the airspeed, this is the speed of the plane with respect to the air, then, and it is 350 kilometers per hour, then the wind is has a speed with a reference to the ground, so this is the speed of the air with reference to the ground, and it is 40, and we need to find the speed of the plane with respect to the ground. Now, according to the law that we said, that the speed of the plane with respect to the ground, it is equal to the speed of the plane with respect to the air plus the speed of the air with respect to the ground. So we have to add the vector PA and the vector AG, but because they form 90 degrees, the vector addition will be equal to the magnitude of the diagonal, and the magnitude of the diagonal we can find it from the root of 350 to the power of 2 plus 40 to the power of 2. So 350 to the power of 2 plus 40 to the power of 2, the result is 352 kilometers per hour. We'll start with question 3. You can pause if you want in order to read the question. However, the question mentions that we have a boat moving in a river with a velocity of 22 meters per second north relative to the water, and the river flows west with a velocity 8 relative to the shore, and we want to find the velocity of the boat relative to the shore. Again, if this is the river, here is the river, a boat is moving in the river north, so this is the speed of the boat. However, the river flows west and it pushes the boat to the west, so basically the boat will follow a path, a course like this. So with common sense we can say immediately that this speed probably again will be the diagonal of the two vectors, so 22 to the power of 2 plus 8 to the power of 2 in the root. However, if we don't understand from the context of the question, we can say that there is the speed of the boat with respect to the water. I call it this BW, and we know that it is 22 and it is north. Then the river flows west with a speed of 8, so there is the speed, the river is the water, of the water with respect to the shore, with respect to the path to the ground, so velocity of water with respect to the shore, it is 8 left, and we need to find the speed of the boat relative to the water, and again we add the velocity the velocity of the boat relative to the shore. So in order to find the velocity of the boat relative to the shore, we need to add the velocity of the boat relative to the water plus the velocity of the water relative to the shore. Again, the first letter needs to appear first, the last letter needs to appear last, and the letters in the middle should be the same. And because we have vector addition, we need to add the vector that it is 22 to the left and 8 plus 8 upwards. So we need to take the Pythagorean theorem, so root of 22 squared plus 8 squared, as we expected. The result is approximately 23.4 meters per second. We continue to the next question, which is that the position of an object, actually this is not related to this topic, this is about the motion on 2 dimensions. It is about the acceleration. We can find it from velocity is equal derivative of position, velocity is equal derivative of position, so we need to derive the position x and then we need to derive the position y, and when we derive the position x and the position y, we can find the acceleration x from the derivative of velocity x and the acceleration y from the derivative of velocity y. We can move on. If you want, you can pause in order to read the question. We have a blue car moving on a road with a speed of 120 kilometers east with respect to someone that it is a stationary pedestrian, with respect to someone that it's not moving. Another car, a red car, is moving towards the blue car with a speed of 85. So the first car, we can say it is moving east with a speed of 120 kilometers per hour. The red car it is moving towards the blue car. So the speed is 85 kilometers per hour, and the question is, what is the speed of the blue car relative to the red car? Now, with common sense, we can answer that as these two cars approach each other, then each of them sees the other car approaching faster than the actual speed. So I suspect that the correct answer is 205 kilometers per hour. So 120 plus 85 kilometers per hour, because the rate that they are approaching is faster than 120 and it is faster than 85. So we have to add these two values. However, if we need a formula, we can say that there is the speed of the blue car with respect to the pedestrian, that it is 120 to the right, then the speed of the red car with respect to the same pedestrian, which is 85 to the left, and we need to find the speed of the blue car relative to the red car, so we need to find the speed BR. According to the rule, the speed BR is equal velocity BP plus velocity PR. Now, the velocity BP, we know that it is 120 to the right. The velocity PR, we don't have it. We have the opposite of it. We have the velocity of the red car with respect to the pedestrian. So it is, since the velocity RP is 85 to the left, the velocity PR is 85 to the right. So the velocity PR is 85 to the right, and this means that if we add 120 to the right plus 85 to the right, the result is 205 as we expected. We can continue to the second question, which is about a boat that it is sailing southeast with a velocity of 40. So southeast is somehow like this. This is the velocity of the boat relative to the shore. Now the river is flowing east with a velocity of 12, and from this we need to find what is the velocity of the boat relative to the river. Now I suspect that since the boat is moving in the southeast direction and there is a river that blows it to the right, then the boat was originally moving downwards. So I suspect that this is the value of x, this is the value of 40, and this is the value of 12, and we can find the x from the Pythagorean theorem, which is a root of 40 squared minus 12 squared. So I suspect that the x will be just a little bit less than 40, probably it's going to be 38.2. However, again, this is with common sense, we can try to find it with physics, and we can say that there is a velocity of the boat relative to the shore, then there is the velocity of the river relative to the shore. These are the two givens, and what we need to find is the velocity of the boat relative to the river. Now again, the rule states that the velocity of the boat relative to the river is equal velocity of boat relative to shore plus velocity of shore relative to river. And again, we have the velocity of the boat relative to the shore is 40 southeast. The velocity of SR, we have the opposite of the velocity SR as a given. The velocity RS is 12 to the right, so the velocity SR is 12 to the left. So we need to add these two vectors. However, since we need to add the 40 to the right and the 12 left, and we don't know the value of x of the velocity PR, as we expected, we have again the Pythagorean theorem. So we can find this x from the root. Actually, we can need to say x squared plus 12 squared is equal to 40 squared. So the x is equal to root of 40 squared plus minus 12 squared, and I suspect that the value will be a little bit less than 40. And it is indeed 38.2. We can continue. You can pause if you want to read the question. However, we can say that we have a boat traveling north with a velocity of 85. The water blows it with a velocity of 60 east, so most likely we'll do the Pythagoras theorem. However, since we have the velocity of the boat relative to the water, which is north, and we also know that the water current flows with a 60 kilometers per hour speed east relative to the shore, so we have the velocity of the water relative to the shore, and what we need to find is the velocity of the boat relative to the shore. Now, according to common sense, this will be the velocity of the boat relative to the shore. However, we can say that the velocity of the boat relative to the shore is equal velocity bw plus velocity ws. So we need to add the vector 85 up plus the vector 60 to the right. Because they form 90 degrees, we need to apply the Pythagoras theorem. So root of 85 to the power of 2 plus 60 to the power of 2. The result will be just a little bit above 100 if I'm not mistaken. And indeed it is 104 kilometers per hour. You can pause for 1 minute in order to read the question. However, what we have is a football player moving with 12 meters per second relative to a defense player who is headed towards him with a speed of 8 meters per second relative to a stationary fence. So if we have a diagram of the situation, somewhere there is a fence that it is not moving. We have an offensive football player that it is moving towards a defensive football player. The defensive football player is moving with a speed of 8 meters per second with respect to the fence. So his actual speed is 8 meters per second. Plus, but the offensive football player is heading. Actually, I should have written it. I didn't see the part that it is moving north, so maybe I should change my diagram a little bit. So this is the offensive football player moving with a speed of 12 meters per second north. The defensive football player is moving with a speed of 8 meters per second with respect to a fence that it is not moving. This speed of 12 is with respect to the other player, so they are approaching with a speed of 12 meters per second. And what is the speed of the offensive player relative to relative to their stationary referee? Sorry, for some reason I read fence. So somewhere here I have a referee that it is not moving. Now we can try to answer this with common sense. Since this speed is 12 with respect to someone that is already moving with a speed of 8 meters per second, it means that the actual speed is now this is his actual speed should be 20, but I don't see the 20 in the options, so probably I have to read the question again. An offensive football player is headed north with a speed of 12 relative to a defensive football player that it is moving west. See, when we don't read the question carefully, this is what happens. So somewhere here there is the defensive football player that it is moving with a speed of 8. So probably we'll need to do the Pythagoras theorem, and somewhere here there is the stationary referee. Now we can say that the speed of the first player, I call it speed of offensive with respect to the defensive, it is 12 up. Then the speed of the offensive player, the speed of the defensive player is with respect to the referee, so this is the speed of the defensive with respect to the referee. and what we need to calculate is the speed of the offensive with respect to the referee. Now, probably the question will be with Pythagoras theorem, but in order to find the speed offensive referee, we need to add the speed offensive defensive plus the speed defensive referee. Again, we need to have the first letter first, the last letter last, and the two letters in the middle common. So offensive defensive is 12 up, defensive referee is 8 to the left. Since the angle is 90 degrees, the magnitude will be 12 to the power of 2 plus 8 to the power of 2. Probably this will be 15. Actually, it is 14.4 meter per second. I think we have one more example to see. Now, we have in an airport, Mansour is walking east with a speed of 2.4, and Hamad is standing on a travelator which moves 1.3 meters per second with respect to Mansour. So 1.3 meters per second faster than Mansour, and we want to figure out what is Hamad's velocity with respect to a stationary observer and outside the travelator. Now we can try to answer it with common sense, or we can try to answer it with the physics law. So somewhere I have Mansour, that it is walking, and his speed is 2.5 meters per second. This is Mansour, and Hamad is standing on a travelator. So Hamad is not really walking, but the travelator is making Hamad. This is Hamad, and his speed is 1.3 meters per second with respect to Mansour. So he's going away from Mansour with 1.3 meters per second. This means that he's faster than Mansour, 1.3 meters per second faster than Mansour. It means that his actual speed for someone that it is standing and observing is 3.8. However, if we cannot understand this with common sense, we can try to say that this is the speed of Mansour relative to the observer, this is the speed of Hamad relative to Mansour, and the speed of Hamad relative to the observer will be equal speed of Hamad relative to Mansour plus speed of Mansour relative to the observer. So we have to add the 2.5 meters to the right plus the 1.3 meters to the right, and this is 3.8 meters to the right. Thank you for watching. Feel free to email me with any inquiries or comments. Have a good day.